2.4 linear functions. In this section, we're getting ready to graph linear functions, linear equations. Slope is represented as m. When you see m in an equation, then you'll know that's your slope, okay? Now, there are two forms of the way you can find the slope. It's nothing but the subtraction of your y's over your x's. So you can do the first point first or the second point first. It does not matter. It will give you the same answer. Now, if I give you 2 points like I've done on the first example, 2, -1, and -3, -3, find the slope. Well, you're just going to plug it in. We're going to take the y numbers, -1 minus -3. Two negatives there in the middle make a +3. My x numbers will be 2 minus a -3. And again, those two negatives make a +3. Do your operation. -1 plus 3 is 2. 2 plus 3 is 5. So your slope is 2/5. Pretty simple. Just plug into the formula. On the second 2 points, I give you -12 and 3, and then 4 and 1. To find the slope, I took my y numbers, which would be 3 minus 1, which will give us 2. Then our x numbers, -12 minus 4, which will give us -16. Like any fraction, you must reduce. So 2 over -16, take the negative to the top, obviously, reduces to -1/8. You had 5, 9, and -2, 9. Forgive you those set of points. To find the slope, we subtract our y's, 9 minus 9, over our x's. 5 minus the -2 makes that a +2. That would give us 0/7. Now, 0 on top of any number, 0 on top of the fraction, this is basic arithmetic, your answer is just 0. So that's what you would tell me the slope. The slope is 0, not 0/7, it's 0. Last set, if you had 3, 4, and 3, 2, and you plug it into the slope formula, 4 minus 2 over 3 minus 3, that would give us 2/0. This time, 0 is on the bottom. Now, 0 on the bottom of any fraction is undefined, meaning it doesn't exist. So you need to be mindful of where 0 is located. If 0 is on the top, then your answer is 0. If 0 is on the bottom, then your answer is undefined. Next, we're going to look at the two major forms for linear equations. They can be written in two forms. You got ax plus by equals c. That's known as our standard form. You also have y equals mx plus b. That's known as our slope-intercept form. Normally, we use slope-intercept form for everything dealing with linear functions, because in this form, you can easily give me the two things I would need to graph, which would be my slope, that's m, and my y-intercept, which is b. Now, ax plus by equals c, standard form, x and y is on the same side, but when you are in slope-intercept form, y is on the side by itself. So hopefully you have downloaded or printed off the little graph paper that I have provided. And let's graph this equation. You're given x minus 2y equals 6. That's our actual problem. And I want to graph it based on using slope-intercept form. Now, if we do that, I've given you the equation in standard form. So we would want to change it to slope-intercept form. To do that, you would solve for y. Get y by itself. So I'm going to move x to the other side. That's always your starting point when putting it in slope-intercept form. Take x to the other side. If I take x over, it becomes a -x. And I just bring down my +6. Now, to get y completely by itself, you got a negative 2 still on y. So I'm going to divide everybody by negative 2. So that's going to leave me with y equals 2 negatives make a positive. That's understood 1 over 2x. 6 divided by negative 2 is a negative 3. This is the exact same equation. It's just in slope-intercept form. So in this form, we know that the slope of the line is 1 over 2 and that the y-intercept is negative 3. Now, in order to graph this line, I already have it graphed for you, but I'm going to explain what I did. I put my first point on my y-intercept. Y-intercept means the point that crosses the y-axis. I'm getting all the way tongue-tied. It's going to be the point that's going to be on this y-axis. Y-intercept, that's where it crosses y. So I put my first point, you see there, at negative 3. Now, from that point, you're going to do your slope. Slope is rise over run. You're going to rise up one line, and we're going to run to the right 2 lines. I like to run to the right. RR, run right. So from that point, we go up 1 line, and I go to the right 2 lines. 1, 2. That's where I made that point. Do it again. Go up 1 line, and over to the right 2 lines. 1, 2. Do it again. Go up 1 line, over to the right 2 lines. That's how I continuously make my points that are going up. To make the points that are going down, I would simply go down 1 and to the left 2. Down 1 and to the left 2. Now, I wouldn't just be concerned with just graphing probably 3 good points. 1 being the y-intercept and then 2 points above it. Now, you do need to be mindful of not only the y-intercept, but the x-intercept. The x-intercept is where this line is going to cross the x-axis. So you can clearly see that that x-intercept is going to be 6. Now, if you had to find it, you would simply let x or y be 0, whoever you're looking for. If you're looking for the x-intercept, you let the y be 0, and you would see that x equals 6. If you're looking for the y-intercept, you let x be 0. And I'll show that written out for you if you need that, because on my labs, you might have to plot the line with just the y-intercept and the x-intercept. Let's look at another graph. (2x minus 3y equals 12). Again, this is in standard form. Let's put it in slope-intercept form. So we're going to solve for the y, meaning the 2x needs to be moved to the other side. And you see I made it negative. I brought down my negative 3y equals negative 2x. Bring down the plus 12. Then to fully get y by itself, you're going to divide everybody by negative 3. That would leave me with y equals 2 negatives make a positive 2 over 3x. 12 divided by negative 3 is a negative 4. So my slope, my m, is 2/3. My y-intercept is negative 4. So when I go to graph, this line is going to cross the y-axis. This is a y-intercept at negative 4. That's where I put my first point at negative 4. Now to make the other points, you do rise over run. You're going to rise up 2 lines. You're going to run 3 lines. So from that point, I went up 2 lines. 1, 2. And I went to the right, run 3 lines. 1, 2, 3. Do it again. I'm going to rise up 2 lines. 1, 2. Run to the right 3. 1, 2, 3. Up 2. 1, 2. Run 3. 1, 2, 3. And then once I have about 3 points, connect and draw. Now here you see that it crosses the x-axis at 6. Next graph. We have x plus 2y equals 8. Again, put it in slope-intercept form because it's in standard. We're going to solve for y. So we're going to move x to the other side by making it negative. Bring down my plus 8. Divide everything by 2. And I have y equals, now that's a negative. It stays negative. That's understood 1 half x. And 8 divided by 2 is 4. So we have y equals 1 half x plus 4. So my slope is negative 1 half. And my y-intercept is 4. So I put my first point on the y-axis at 4. This is where 0 is. 1, 2, 3, 4. Y-intercept. Now from that point, this time my slope is negative. Now if you have a negative slope, that means you're not going to rise. You're going to fall. I take care of the negative by going down 1. Okay? So I'm going to go down 1. But I'm still going to run right. Run right. Run to the right 2. Go down 1, run to the right 2. Down 1, run to the right 2. Keep in mind your movements. When you're dealing with a grid, if you go down indefinitely, all of these numbers are going to be negative. If I come to the left indefinitely, all of these numbers are going to be negative. Those are negative movements. Down and left are negative. If you go up, if I continuously go up, that's going positive indefinitely. And if you go to the right, that's going positive indefinitely. So keep in mind, up and right represent positive movements. You only have one part of this that's negative. So you only need to do one negative movement. I go down. That's a negative movement. But I must go to the right to make it a positive movement. You understand? That way your line will be going in a downward motion. If you follow this line like we talked about in 2-3 and you follow it, you're going down, you're decreasing. And that has to be the case because the slope is negative. If we go back and look at the last example and even the first one, our lines are increasing. They're going up because my slope is positive. Even if you look here and see I had 2 negatives, 2 negative movements make a positive. That's the reason why you're going up. That's why we rise and we run to the right. Here, you only have a 1 negative movement. So you only do one thing that's negative, which I would go down. Now you could go up and go to the left. You could go up 1 and come to the left 2. Up 1, left 2. You only can do one of them. Either you do left or you're going to do down. And that's a line with a negative slope. Our fourth example, we have 3x plus y equals 4. So again, put it in slope-intercept form. When I move my x over, it becomes a negative 3x. And I bring down the plus 4. And my y is by itself. There is no number on it, so it's already in slope-intercept form by doing that one movement, which was just move my 3x. So now my negative 3x is my m, and my positive 4 is my y-intercept. Now, if you have a number that is not already in fraction form, there's an understood 1 at the bottom. So when you do your rise over run, you're going to fall 3 lines, but we're going to end up running 1 line. Okay? So I put my first point at 4 on the y-axis, and from there, I'm going to go down 3 lines. 1, 2, 3, and to the right 1 line. Down 3 lines. 1, 2, 3, to the right 1. Again, down 3 lines, to the right 1. Once you have about 3 points, you can connect. Again, this line has a negative slope. You see it is going, it's decreasing. fifth example, we have 5y plus 3 equals 18. Now, if you notice, there's no x in the entire problem. So this is considered a special line. There is no x. So I still solve for y. And when you solve for y, you subtract your 3. 18 minus 3 is 15. And then I divide by 5. That would give me 3. So y equals 3. That's all your equation is. It's a y-only line. No x. So that means you're going to go to the y-axis at 3. And the only way I can make a line through that point without crossing x, I can't cross x if x is nowhere in the problem. Okay? There's no x in that entire problem. So it never will cross the x-axis. Now, it will run parallel to the x-axis, meaning that they run the same way but never touch. But it's never going to cross it. So that's considered a horizontal line. Okay? Horizontal line is a y-only line. It's going to go through your 3 on the y-axis. Now, you need to know the slope of all horizontal lines is 0. The slope of that line is 0. The y-intercept of that line is 3. That's where it's crossing the y, is at 3. It does not have an x-intercept because it never will cross the x-axis. This is a special line. This is our horizontal line. Our next example is going to be x plus 7 equals 12. Now here, you have no y. There's no y in that problem. So this is another special line. This line has only the x variable. Now this is the only line that we go to the x-axis and start to graph if we're going to use the slope-intercept form. So this one says we're going to solve for x, subtract our 7. 12 minus 7 is 5. So we have x equals 5. This is an x-only line. So you go to the x-axis first because that's your only directive. You don't have a y. So you go to x-axis at 5, and the only way I can draw a line through that point without touching the y-axis, I can't touch the y because I don't have a y. So I'm going to draw a vertical line up and down through the 5 on the x-axis. Okay? This is your vertical line. Vertical lines are our x-only lines. Now you need to know that the slope of all vertical lines is undefined. It has an undefined slope. So again, recap, our two special lines. You have the horizontal line where you only have y. It's only going to cross y. Does not cross x-axis. His slope is 0. Our vertical line is only going to cross x. There is no y. And its slope will always be undefined. Last example. We have 3y equals x. So to get y by itself, all we're going to do is divide by 3. X was already on that side. We're going to divide by 3. So we have y equals 1/3 x. Now this one is not special. It's short, but it's not a special line. It still has y and x together. Okay? What I mean is it has an x in the equation and a y in the equation. In order for it to be special, like the previous two examples, you can only have just x or just y. So this one has an actual slope of 1/3, because that's what's on our x. And I drew a cloud out here because it doesn't have plus or minus a number. So that lets us know that it has to be 0. It's going to go through the origin. It's crossing at 0. So you're going to put your first point at 0. And then you're going to do your rise over run. You're going to rise up 1 line. And you're going to go to the right 3 lines. 1, 2, 3. Up 1, right 3. 1, 2, 3. Up 1, right 3. 1, 2, 3. Now I will show, because on my labs, you might have to plot your points by using X and Y intercepts. So if you remember the graph, the first one that we did, or the second one, it was 2x minus 3y equals 12. If I want to find my x-intercept, if I'm looking for x, you simply let y be 0. So if I let y be 0, then it's gone, okay? You're only going to have 2x equals 12. So if you divide by 2, then x equals 6. So that means the point that is crossing x-axis is going to be at 6, 0. You let your x is 6 and you let your y be the 0. So that would be considered your x-intercept. Now, if I'm looking for the y-intercept, without me putting in slope-intercept form, you're going to simply do the exact same thing. You're going to let x be 0 this time. So if I let x be 0, that's gone. You got negative 3y equals 12. So when you divide by negative 3, y is negative 4. So your point would be 0, negative 4. That's my y-intercept. And if you go back and look at that graph, that's what our b ended up being, was negative 4. But I do want to show, because you might have to use the let x be 0, let y be 0 to actually graph on the actual graphing tool for my labs. Now this will conclude graphing equation of a line for 2.4.